Hey guys. So today we need to talk about alternative bases and change of basis formulas. So to that end, let's make an example space. So let me let V be R2, but with a basis that's different than the usual. So my basis for R2 right now is going to be 1, 1, and negative 2, 2. There's nothing particularly special about this. This was just kind of me picking a couple of random things. And then let's have just a quick little example here. So my example is going to be to try to write the vector 11, negative 1 in terms of v. So 11, negative 1 is going to be our standard basis vector, and I'm going to try to write this, come on, go away, as a vector in v. Okay, so in order to do that, my first thought's going to be, alright, well, if it's going to be a vector in v, that means it's going to look like some constant times the first basis vector plus some other constant times the second basis vector. And I'm going to make this into 11, negative 1. And I'm hoping that you guys are at the point where you're noticing this looks a lot like the column multiplication picture. So I could probably just rearrange this into this alternative problem where I put this matrix together, right? This matrix I'm actually just going to call the V matrix. That's just the two basis vectors jammed into a matrix, right? So I'm thinking about this matrix as it's V1 in the first column and V2 in the second column. And then I'm going to multiply this matrix by a vector C1, C2, and out of this I'm going to get the vector 11, negative 1. Now if I take this and cram it into an augmented system, like let Desmos help me out, or otherwise solve this somehow, I'm going to get that the vector C1 and C2 is 5 and negative 3. So what that means is in V, so this is me just kind of writing down in summary, 11, negative 1 as a vector in standard R2, so I'm not writing anything down here, is equal to 5, negative 3, but written in V. So that's really all there is to this. So let's try this again. Let's take another example. So let's let a space W be R2, but with a basis of, let's see, what was my basis I wanted to use? Negative 1, 3, and 0, 4. Okay, so I'm going to do my exact same problem again. So I'm going to do my example. I'm going to write the vector 11, negative 1 as a vector in W. Okay, so same thought, right? I'm going to have like D1 times negative 1, 3 plus D2 times 0, 4 is going to give me this new vector 11, negative 1. I'm going to convert this to a matrix system and ref it, right? So I'm going to get negative 1, 3, 0, 4 augmented by 11, negative 1. We're going to go ahead and ref that, and what we're going to end up with is we're going to get that D1 and D2 are equal to negative 11 and 8 out of this. Okay, now the trick for this is that there's kind of a cool thing you can do now that you've got a vector written out in two different ways. So I can say, all right, look, so my example vector, 11, negative 1, in the standard basis, is equal to, well, it's equal to the version in V. So the version in V is this guy, 5, negative 3, right? So I can write that out as it's 5 times 1, 1 plus negative 3 times negative 2, 2. Or I could write it out as it's negative 11 times negative 1, 3 plus 8 times 0, 4. Right? Now, the trick with this, the thing that's kind of cool, is I can then rearrange these guys just a little bit. So I can rewrite this guy here, thinking about my matrix V, as this is V times the vector 5, negative 3. And that's the V version of my standard basis vector. And I can rewrite this guy as W. That's this matrix, right? That's going to be this first basis vector and this second basis vector, times this vector negative 11, 8. And that's in W coordinates right now. And the cool thing is I could do this for really kind of any vector, and then I could come up with a way to convert between coordinates. So the conversion is going to be like, okay, if I want the W coordinates, I need to take this W and move it to the other side. So the V to W conversion is given by U written out in V version, right? It times V times W inverse is U written out in W coordinates. And the W to V conversion, is written out as same deal but opposite, right? So I want the UV is the result, and that's going to be written out as V inverse times W UW. So these things here, these conversion matrices that I've just labeled, this thing here is the change of basis from V to W. And we usually call that a matrix. So we have the change of basis matrix from V to W there. Here, this guy is the change of basis matrix from W to V. So it is a little confusing, the kind of backwards feeling. You just really have to actually put this in your head. To illustrate what's going on here, I want to bring in a little Desmos picture quick. So here I've got, let me make this just a little bit smaller so we can kind of point at some stuff. Okay. So I'm looking here at my little Desmos picture, and I've got my kind of first thought here. So here I've got my vector 11, negative 1 in my standard basis. That's this green vector. I'm going to turn on some vectors in V. So these are my two basis vectors in V. And I found out that the coordinates were 5, negative 3, right? So essentially, if I scale this scale the red vector, red's the first vector. If I scale the red vector up by a factor of 5, and then scale the blue vector by a factor of negative 3, and then I want to put the blue vector at the tip of the red vector, so I'm just going to add where the red vector ends up. So there I've got the green vector expressed in terms of red and blues, right? Now we could do that same thought. So I'm going to shut that guy off, and I'm going to look at W here. So I'm going to turn W on. Here are my two basis vectors in W. Oops. Like I said, here are my two basis vectors in W. And then I need to scale that first one. Whoopsie daisies. No, that's not what I wanted. That's what I wanted. I need to scale that first one by a factor of negative 11. So this guy, we're going to go from negative 11 to 0. So there's orange vector scaled by a factor of negative 11. And then I need the purple scaled by a factor of 8. And then I need to start the purple where the orange left off. So that's going to be starting from 11 and negative 33. There we go. So I've got my green vector that I can either write as blue and red or as purple and orange. Either way is fine, right? Like, these are the same vector. They're the same vector as me talking about the green vector in terms of the standard basis. This is just different ways to think about this thing. And if I wanted to make a conversion between one basis to another, I could use these conversion formulas. These are the change of basis formulas that you'll see in the book. Thanks, guys. Catch you on the next one.